Alright, so let's begin. So this is the first revision session for the entire. Okay, so we have two more. Tomorrow we have revision session 2, and day after tomorrow, Friday, we are going to do mock session. So mock session is like we have released the mock exam for you guys. Please do try to solve it, and on Friday we will discuss the solutions of that particular essay. Okay, so let's begin. So in today's session, we will be covering week 9 and 10, and tomorrow we will cover week 11 and 12. And week 1 to 8, you have to prepare on your own. But I will just give you where to focus. Okay. By giving you this end term exam blueprint. So the syllabus for end term will be from week 1 to 12. But as you can see from each week weightages, it will be predominantly week 9 to 12. Okay. So there will be one question or one and a half question from weeks 1 to 8. Okay. So it carries only 5 to 10% of the marks. And also focus majorly on week 7 and 8. Okay, so just leave out week 1 to 6. So 7 and 8, where this power series has come, right? Taylor series expansion, and the integration, of course, week 8. Okay, so solve problems related to that, and the question will also be relatively easier. Okay, so we know that you won't get time to prepare for week 1 to 8, but you should know the concepts. Okay. So the total time for this exam is 90 minutes. So you'll get 30 more minutes compared to quizzes. So it's 1.5 hour exam. And the total marks is the same. So it is same as week 1 and week 2. So just hold on. Yeah, so the total marks will be for 40 marks. And you can see each week weightages. Even in week 9 to 12, there will be a little more weightage to week 9, 10, 11 compared to week 12. Okay. So you can say half question will be lesser in week 12. Alright. So and coming to the pattern, there will be comprehension type questions only. Okay. So all the questions that you see will be comprehension. 9 comprehensions, 5 are relatively easier compared to the other 4. So 5 easy comprehensions each will carry 4 marks. So that means each part will carry 2 marks each, or 1 and 3 marks each. Okay, and the 4 medium comprehension type questions will be slightly, not even hard. Okay, so I wrote medium, will be slightly computationally loaded, you can say, compared to that 5 easy comprehension type questions. Okay, so here also each comprehension contains 2 questions, and it will be 2 plus 3. So one question is 2 marks and other question will be 3 marks. All right, and also the weightage split between MCQs and NATs, there will be equal weightages. So 20 marks you will see MCQ or MSQs. Okay, so I hope you know the difference between MCQs and MSQs. And the other 20 marks will be numerical NATs, numerical answer type. Okay, so roughly, approximately. So there will be equal weightages. Okay, and one strong note or one good way to prepare for end term is please do solve the mock test. Okay, so mock test has been released. Please to solve the mock test. And also, not only solving just the mock test questions, solve questions that are of same type in mock test. So you'll see some questions, right, in mock test. So solve problems related to those questions, like replicas or around those topics. So your preparation should be in this basis. If you have very less time, so you start with these concepts. Okay, so that is about the enter. Okay, so as I said, this is really important. If you are not doing it, then your easy way of getting marks is slightly trickier, becomes hard. Okay, so let's come to the main agenda of today's session. So we are going to revise week 9. Or is that so? That we can't do anything. So this was decided long back, and we usually do 4 to 4:13, 4 to 6, no, every time. Just do one thing. You can finish that and come here, and or you just watch the first half an hour. As I am going very slow, the first half an hour will cover very few things. Okay. So the important concepts that you have to revise in week 9 and 10. Definitely, you should look into the applications of integrations. What do I mean by applications? You have to, given two curves to you, you should be able to compute the area between the curves. Okay, so this and arc length computation and volumes. So volumes, I mean, so given a region and it is revolved around x-axis, right? So you remember this part, right? So given a region and it is revolved around x-axis and a volume will form, and how to find the volume of that particular uh, shape that we get. Okay, so that is also important. And finally, antiderivatives. How do we compute the antiderivatives or the integrals using logarithms? So this will cover week 9. Right? So the first 4 concepts are important for our random exam. And from week 10, you should definitely know what a complex number is. And then all the arithmetic on the complex number you should know. So like given a complex number to you, complex numbers to you, you should be able to add, multiply, divide. You should be able to take the conjugate. You should be able to compute the absolute value of a complex number. And then you should be able to write a complex number in its polar form, right? So that is also really important. So all those things are really important, and it carries a huge weightage. As I said, week 10 carries the highest weightage. Oh, yes.
Sir, we have another live session also for the ESTC, and this live session for mathematics also. How can a person join these two at the same time?
Huh, that's a good question. But I can't do anything. No, no. So should I stop my session?
No, no, sir.
No,
That's
right?
what I
So
no.
so I can't do anything. If see this was scheduled previously, and we usually do this, right? So quiz one we did this, quiz two we did this. Even the end term we are following the same schedule. So maybe you should ask ESTC instructors. I'm not sure why they scheduled at our time. Okay.
Okay.
Or my suggestion is anyway 15 minutes is done now. We didn't even start. Okay, so anyway till 4:30 I at max cover one or two topics. Then we will increase the pace. All right. So okay, let me come back. So in week 10, the arithmetic with complex numbers is really important. And you should know what this Euler's formula is in order to convert this x plus iy into e power I theta. Right? So that is also important. And finally, if you have time, just cover roots of unity. So this is important. This is important. This is important. So this is slightly important. This is important. And this is also. So 1, 2, 3, 5, 6, you should definitely, if you didn't prepare or if you didn't revise, passing itself will be very difficult for you. So 1, 2, 3, 5, 6 are really important. And 4 and 7, if you want to gain more marks or if you want to do the problems in a smarter way, 4 and 7 also you should revise. So along with this, having said all these things, after you finish this revision, if you want 100 out of 100, then definitely you should go through all the topics. So this important concepts that I am showing you right now will fetch you 75 to 80% of the marks. And when you do mock and all, that will fetch you some 5-10 marks. So you let max reach 90. So in order to get 100, you should prepare everything. Okay. So don't ask me after the exam. Don't come to me saying you didn't tell us that particular question is important. Okay. So this important I mentioned for 80% of the questions. Okay. So 80% of the questions you can expect from these concepts. So that is why revising these are really, really important. Okay. So let's start with the first one. First application. How do we compute area between two curves? Right. So there could be two possibilities. One, given two curves, there is no intersection at all, and you will have a nice blue curve floating on the top and green curve floating below, and you will have this region R very neatly. So if I have to compute the area of this region, all I have to do is to integrate from the lower limit to upper limit, the difference between the top curve minus the bottom curve. Right. So which function is maximum, that you will take first and subtract the smallest one. Right. So that's the area of the region R we get. What if there is an intersection? Right. So on the right hand side you can see, if there is an intersection like this at point C, right, my curve g of x will look like this and f of x will look like this, and in the interval a and c, you see that your g of x is above and f of x is below. And in the interval C to B, you are seeing that f of x is above and g of x is below. So in order to compute the area between the two curves, no matter which curve is above or which curve is below, you should always take the difference between the top curve or the above curve minus the bottom curve. Okay. So here there is an interchange, right? So suddenly g of x is coming down and f of x is going above after point C. So what you will do is you will break the integral into sum of two integrals, right? And from A to C, you will take g of x minus f of x because g of x is above and f of x is below. From C to B, you will take f of x minus g of x, right? So like that, and you will add both. And in order to find this intersection point C, what we will do is we will equate f of x to g of x and solve that particular equation, right? So we will equate these two and find the intersection point, and then if at all there is an intersection point, and also the note is this intersection point should be between A and B. So if you got some intersection point which is outside of this interval AB, you don't have to care about it, right? So if you see from the graph also, C is lying between A and B. Okay, so your intersection point, or when you solve this equation, you might get more than 2 or 3. But out of 3, you should see which point is actually inside the interval A. Okay, so that you should really take care. Okay, so sometimes you may also be asked, like, given two curves, what is the enclosed area? What will you do? So something like this. So you have one curve like this going, you have another curve like this. What do we mean by enclosed area? We won't give you A and B. So I have an example, I will show you. But which region is called the enclosed region by the two functions? Anybody? I say this is f of x and this is g of x. if I am saying enclosed area between f of x and g of x, what do I mean by that? Yeah, go ahead. Anyone? Okay, so let me say. So the enclosed region is like, so the region should be closed. So it should be like a closed region. So this is the region. So this is the enclosed region between f of x and g of x. And strong note, this is not an enclosed region. Okay, so this is not closed. So this is like it is going infinite region. It has infinite region. So this is not an enclosed region. Okay, so the enclosed region is this. Now, if this is the enclosed region, you need these 2 points, right? It's basically the intersection points of f of x and g of x. So if the question is like this, so this is the first example we have. So you have two functions given to you, okay, f1 of x and f2 of x. We just said find the area enclosed by the two functions. That's it. We didn't give you the lower limit or the upper limit. What you have to do, that I will explain in 2 to 3 minutes. Okay, so just try to solve it. As I said, keep a book and pen with you and take some 2 minutes time. At least think of how you will solve this particular problem. Okay. Okay, so I request everyone to try to solve because we have only hardly 4 days to enter, right? So this gives you a good practice for enter. Okay, so what should we do? If I have to find the area, then
Sir, we need to find intersection first.
correct. So the first step, step one should always be find the intersection points.
Yes, sir.
Correct. Nice. And how do we find that? We just have to equate f1 of x to f2 of x. Right? If I do this, what will I get? I will have f1 of x to be x square minus x minus 6, which is equals to minus x square plus 3x plus 10. What I got is a quadratic equation. Right? So I will pull everything to left hand side. If I do that, I will have 2x square minus 4x minus 16 is equals to 0. I can further simplify this by pulling out 2 from each and every term on the left hand side, and I can divide by 2 throughout. I will have x square minus 2x minus 8 is equals to 0. Okay, so we reached here. Now what? So what are the roots for this quadratic equation?
Sir, 2 and minus 4.
2 and minus 4. Very good. So it will be 2 and minus 4. And you can just use the factorization method. You don't have to use the formula also. So this minus 2x, you can split it like minus 4x plus 2x. It is minus 2 and plus 4, no?
Yes, sir. Yes, sir. Minus 2 and plus 4.
Right? So you just have to factorize the middle, minus 2x as minus 4x and plus 2x. From these two, you just pull out x common. From these two, you pull out 2 common. And you will see you pull out x minus 4 common from both the terms. Then you will have x plus 2 into x minus 4, which will give you x is equals to minus 2 and x is equals to 4 are the roots. Once you have these roots, now these will be our limits for the integration, right? So these will be our limits. And this is the upper limit, sorry, lower limit. And this is the upper limit, right? So area is actually integral minus 2 to 4. Now what should I write in the inside integral? Will it be f1x minus f2x, or will it be f2x minus f1x? That we only know when we know what happens to f2 of x and which one is larger, bigger, right? Larger. Is it f1x or is it f2x? For that we need a rough plot, right? So you should know how f1x looks and how f2x looks. So if you see f1x, x square minus x minus 6, I can write this as x plus 2 into x minus 3. So I can factorize it. Even minus x square plus 3x plus 10, I can write it as minus of x plus 2 into x minus 5. Right, so this is the quadratic function with the leading coefficient as positive. Will it be an upward parabola or downward parabola? f1 of x. So it should cut minus 2 and 3.
Sir, it will be 4, I think. X plus 2 and x plus x minus 4.
Oh, is it? No.
No.
It will be x. Correct only. X plus 2 into x minus 3.
Yeah, correct.
But f1 of x will be an upward parabola. Right? Because the leading coefficient is positive.
Yes.
Right? How will f2 of x look? It is a downward parabola because
Yes,
the
sir,
leading
because
coefficient is negative.
yes, sir.
And it should also pass from minus 2 comma 0 and 5 comma 0. So something like this. Right? So this is 5 comma 0. And this is minus 2. So you need to have a rough plot. So these are not the accurate plots, okay? And the intersection points are minus 2 and 4. So that means this is one intersection point and the other intersection point is happening here at x is equals to 4. Now the area enclosed between these two is this one. And within this interval, minus 2 to 4, my red curve is above and blue curve is below. So that means the downward parabola is in the upside. So the downward parabola corresponds to f2 of x. Right? And the upward parabola corresponds to f1 of x. So f2 of x is above and f1 of x is below in the interval minus 2 to 4. So that means the integrand will be f2 of x minus f1 of x. So don't get confused here, okay? Also, even if you do f1 of x minus f2 of x, you know what will you get? You will get the negative of the exact answer. Okay, and we all know areas will not be negative. Right?
Yes, sir.
So when you get a negative answer, it means that you took it in the wrong way. Okay, so now this is the correct way. Yes.
So the 4 is positive.
Sorry.
So x is equal to 4. That is minus 4 only, sir. Plus
This
4.
will be minus 4. It will be plus 4, no? So, okay. So, let me solve this. So, you have x square minus 2x.
The delta is minus 2.
and minus 8, right? Even if you don't want to use factorization, if you are getting confused, use our friend quadratic formula. So it will be minus b, right? Here b is minus 2. So write down a, b, c values. A is 1, b is minus 2, c is minus 8. Now x will be minus b plus or minus root b square minus 4ac divided by 2a, right? So this is a quadratic formula. It's very hard to forget, right? So b is minus 2, so minus b will be 2 plus or minus square root b square is 4 minus 4 into a is 1, c is minus 8 divided by 2 times a is 1, 2. So 2 plus or minus square root 4, and this is minus and minus inside. So 4 into 8 is 32, minus and minus becomes plus, so plus 32 divided by 2. So you'll have 2 plus or minus square root 36. Square root 36 is 6 divided by 2. So one root is 2 minus 6 by 2, and another root is 2 plus 6 by 2. So this 2 minus 6 by 2 is minus 4 by 2, which is minus 2. 2 plus 6 by 2 is 8 by 2, which is 4. So minus 2 and 4 are the roots. Okay. So this is correct. So the lower limit will be minus 2, the upper limit will be 4. And within this interval, f2 of x is greater than f1 of x. So that is why your integrand will become f2 of x minus f1 of x. Now f2 of x you substitute. Right, f2 of x is minus x square plus 3x plus 10 minus f1 of x is x square minus x minus 6. Now this will just be minus 2 to 4 minus 2x square plus 4x plus 16. And we know how to do this integral, right? So we know what's the integral of x square, what is the integral of x, what is the integral of constant. Okay, so if we use the formulas, x square integral will be x cubed by 3 plus 4x integral is x square by 2 plus the constant is 1 x, right? So 16x, and the limits are 4 and minus 2. From here it is just substitution, it's just computation. Okay, so if anybody has computed it, you can let me know the answer. So this is minus 2, 4 cubed by 3 plus 4 into 4 square by 2 plus 16 into 4. Right, so let's substitute the first limit. Minus 2 into minus 2 cube by 3 plus 4 into minus 2 whole square by 2 plus 16 into minus 2 for the lower limit. Now I have to compute the answer, which I'm not going to do. So you should solve this and get an. So if you are getting an integer, it's fine. If you are getting something rational, you just have to write it in some 2 decimal places, up to 2 decimal places or 3 decimal places, which will be given in the question. Okay, so this computation part, you should not go wrong, definitely. And also theory part also, you should be clear about what's your step 1, what's your step 2, and what's your final step. Okay, so be clear what is asked. Okay, firstly read the question very carefully. What is the information given to you, what is asked. After that, you decide how should you start. So for this particular problem, you should start by finding the intersection points, because the lower limit and the upper limit is not given explicitly in the question. You have to find them. For finding them, you need this intersection point. So after finding the intersection points, the next step is to find which function is greater, whether f2 or given, if at all there is only 2 functions given, you just have to compare them, and the integrand greater one minus the smaller, and just computation. The last step is like computing. Okay, I hope this is clear. Moving on to the next application, which is arc length. So given an arc like this function, and function can be very smooth between a and b, then the arc length is given to be integral a to b square root 1 plus f prime of x. It's not f of x. You have to take the derivative of the function whole square dx. And proof, I think now is not the time to deal with the proofs. Okay, so proof has been extensively done in the lecture. Okay, you just go back and see the proof. Okay, so what we are doing is we are just computing this length. Okay, so if this length is stretched like this, so what is the length from here to here, right? So here it is curvy. We don't know how to compute the curvy length, so we use this arc length. So we slowly take each and every point and we just put like a straight line and see the total length. So that is the arc length. Okay, for that this is the formula we have derived this. Okay, now a small example for arc length, the kind of problems. See, if f of x is itself is very complicated, then taking the derivative will take some time, right? Kill some time. So sometimes we ourselves will give you f prime of x, just like in this particular problem, we give you g prime of x. Okay, you don't have to take the derivative once again. Okay, given g prime of x, you have to compute the arc length of the curve g of x from this point to this point. All you have to do is substitution. And substitution. If you know the formula, and the formula, this is the formula. You just have to identify what is A, what is B, what is f prime. That's it. Only three things are required to. So A you'll get from here, A is root 2. B you'll get from here, which is square root 26. F prime of x is g prime of x, which is 1 by square root x square minus 1. That's it. If I substitute, arc length will be integral square root 2 to square root 26 under root 1 plus 1 by x square minus 1 square root x square minus 1 whole square. Right, so f prime of x whole square dx. Right, so if we simplify this, we'll get square root 2 square root 26. You see, there is no major trickiness involved in this kind of problems, right? So if you know the formula, if you can identify the variables a, b, and f prime of x, all you are doing is substituting and calculating, right? So you should not go, definitely should not go wrong in these kind of problems. Okay, straightforward questions. You should practice too many problems so that you will not go wrong in these kind of problems. So this is square root 1 plus 1 by x square minus 1, because square and square root will get cancelled out. You will just have 1 by x square minus 1 dx, and this will be square root 26 x square minus 1. If you just simplify this, you will have x square minus, in the numerator you will have x square minus 1 plus 1, you will have x square, and square root is there. So if I do all those things, I will have, I'm not writing mod x, right, because it's in between square root 2 to square root 26, both are positive. So square root x square will be x itself. And here in the denominator, I will have square root x square minus. So till this point, we can reach, right? So after this point, you know, if you want the integration formula or the techniques. So one of the nice technique here we can use is substitution. So this is different substitution. So change of variable. So what we do is we put or substitute some new variable p in place of x square minus. So why are we doing this? If we do this, then dp will be 2x dx. But if I derivate on both sides, I will have dp is equals to 2x dx. Why I need this? So you see this x dx, I can write this as half dp. Right? So from here this. So this x dx, I'm replacing it with half dp. So I'm eliminating this x in the numerator. So this whole x dx will now just simply be half dp. And this 1 by square root x square minus 1. So if p is x square minus 1, then 1 by square root x square minus 1 will be 1 by square root p. Right. So I just have to replace x square minus 1 by p. So this green part will just be 1 by square root p. So along with this, along changing inside the integrand, you should also be very, very careful with the limits. So these are the limits for x. So you have to change it with respect to p. Right? So since I have substituted p is equals to x square minus 1, we will use this. So when x is root 2, for the lower limit, I have to substitute x is equals to root 2. So p will be root 2 whole square minus 1. So 2 minus 1, which will be 1. P's lower limit is 1. And lower limit of p. And for upper limit of p, I have to substitute x is equals to square root 26. So if I substitute square root 26 and square it minus 1, I'll have 26 minus 1, which is 25. So 1 and 25 are the limits. Now, after this change of variable, my new integral will look like this. So I have to integrate from 1 to 25. And 1 by square root x square minus 1 will just become 1 by square root p into that x dx will just become half. Right, so this is technique you should know. Right, along with the computation, you should know these small techniques. So now it's very simple. So this is like half I can pull out. This is integral 1 to 25. 1 by square root p is basically p power minus half dp. We know x power a is integral, right? So using that, we'll have half p power minus half plus 1 divided by minus half plus 1. And the limits are 25 and 1. Alright, so from here, it's a substitution, which I'm not going to do. Please do solve. So I'm not giving you answers because you should solve this. At least from this point, you should be able to solve and get to the answer. It's not that I don't know the answer. Okay. Alright, so that is how we solve problems related to the arc length. The arc length problems are really straightforward. We can't complicate too much in that. Given g prime of x, given the limits, you just have to substitute and do the integration. You should be good at integration. Okay, so yeah, so the third application is about finding the volumes obtained by revolving region along x-axis. So again, here also we have f of x in some interval ab like this. Okay, so now what we are doing, we are going to rotate this particular region, this whole region around x-axis. So when you rotate, volume is formed, right? So you will form a volume. So this will be like this, right? So you'll have, sorry. Okay, so it will be like that. So some glass. Think of it like that, right? So some wine glass. So it will be looking like that. So it will have some volume. and we have to compute that. So how do we compute that volume? Again, this proof also discussed in the lecture. You can compute that volume by using this. So all you have to do is you have to integrate from a to b pi f of x whole square dx. Right? So that's it. This is also very fairly straightforward. No major issues with this also. So you have been given some g of x to you, and what you have to do, you have to compute the volume obtained by revolving g of x around x-axis between x is equals to 2 to x is equals to 4. Right? So all you have to do is to identify. So 2 is your a, 4 is your b, and f of x is your x square plus 2. So therefore the volume just simply become integral 2 to 4 pi x square plus 2 whole square dx. So from here we can do 2 to 4 pi. If I do the square, it will be x bar 4 plus 4x square plus 4. Right, so you know integral of x bar 4, you know the integral of x square, you know the constant. You can pull out pi out first. So this will just become x bar 5 by 5. Right, x bar 4 integral is that plus 4x cubed by 3 because x square integral is x cubed by 3 plus 4x. And the limits are 4. Right, you just have to substitute 4 ones minus substitute 2 ones. Yeah. Right. Again, I'm leaving it here. You guys have to solve from here. From here, it is just solve. Okay. And volume is straightforward again. You have the formula, ready-made formula with you. You just have to use the formula by substitute. Okay. All right. So moving on. Quick briefing about logarithms. I will not spend too much of time. Because logarithms are basically defined as the integral, running integral from 1 to x, 1 by t dt, and this is only defined when x is greater than 0. Okay, if you see the right side graph, the log x graph will start from x is equals to 0, not even x is equals to 0, x greater than 0, and it goes till infinite, positive side. So you'll not have any negative side. And there are many properties from the graph itself. We can write many properties. Right. So first and foremost one is log 1 is 0 because it intersects x-axis at 1. Right. And limit x tends to my 0 log x. 0, that too from the positive side, log x will be minus infinite, and log x is an increasing function. Right, so you can see from the graph it's increasing. Just a second. Yeah, so the log x is an increasing function, and what else? As x tends to infinite, log x goes to infinite. Right, so these are some properties that you can see straight away from the graph. If you know the graph, then all these properties are very tricky. And the other thing is log x is basically the inverse of exponential. So logs are inverse of exponential. So that means if I take log of e power x, or if I take e power log x, the composition of these two functions, I will get x. Okay, and even graphically also you can see. So e power x will look like this. So both of them are symmetric along this y is equals to x line. Right, so if they are symmetric along y is equals to x line, they are inverses to each other. This is e power x. This is e power x and this is log x. Okay. And yeah, I think these are few properties. You can go through other properties also. But why we introduce logs here? What's the necessity? Because it helps in finding the antiderivatives. Okay, so you have some function, some special kind of function where it's a rational function and the numerator is just the derivative of the denominator. Something like this. U prime of x divided by u of x, where u of x is not equal to 0. So if you have these special functions, special I mean the numerator is just the derivative of the denominator. So if you have like this, then the antiderivative will just simply be log of the denominator plus some constancy, particular constancy. Okay, so you don't have to do integrations or anything. So a quick example on the antiderivatives is this. So you have h of x like this, okay, and we were asked to find the antiderivative of h of x. So if it is any other rational function, it will be slightly trickier to find the antiderivative in one step, right? So you have to use some integration techniques and all. Whereas if you see this h of x, it falls into our special case. How it falls is you take the derivative of the denominator. You know the denominator, right? So this is the denominator. You take the derivative of this. We'll see that the derivative will give us 3x squared plus 6x minus 3. So 3x squared plus 6x minus 3 and x squared plus 2x minus 1 in the first glance may look different. But if you carefully observe, by taking 3 common from each term here, you'll see that you'll get x squared plus 2x minus 1. So this is exactly the numerator. Right? So what will happen if I have to find the antiderivative of h? All I have to do is just multiply 3, which will make me 6 and 3, and I will divide by 1 by 3. So 1 by 3 is anyway constant, which will not play any role in the integral. So I can write 1 by 3 here. And it will not affect. But this now becomes exactly my special function. If I compute the antiderivative, it will just become log of the denominator. I just write log of absolute value of the denominator. Log of x cubed plus 3x squared minus 4. Some constants. You see one step. Only one step. Okay, so this is my notes actually. It means it's not my own notes. It was generated from professors itself. But I created this video. Okay, but the flow is what professor taught in the lecture. Okay, so it is like a one go, right? So one step you can find the antiderivative. It is a special function and this log is helping us, right? So log comes in directly. Alright. So that's about week 9. Okay, so week 9, I said 4 concepts are really important. One is you should be able to compute the area between the two curves, whether there is no intersection point at all, or if there is intersection point, you should be able to find the intersection point and then compute the area, right? Or sometimes if we don't give you the limits, if we ask just the area enclosed by two functions, you should start by finding the intersection points, which will act as your limits, right? So from then on, the same approach you follow. The next thing is about the arc length and volume. Arc length and volume are more or less like formula driven. So you just have to remember the formula. But if you forgot also, then you have to sit and derive. But it will not happen. It is very easy. If you understand the concept really well, if you just follow through the professor, then formula you will not forget the form. Then you just have to substitute. That's it. Okay. And volumes also obtained by revolving is also a formula driven, and you just have to identify the variables and substitute them, compute. So in all the cases, you should know, you should be really good at integration. Okay, so that is why in order to do good in week 9, you should definitely need week 8. So the integration techniques are really important. Okay, then couple of things about logarithms, and logarithms we use them majorly in this particular course. At least we have used logarithms for finding the amplitude. All right, so we will quickly take 3 to 4 minutes, maybe 5 minutes a break. Okay, so just refresh your brain, just relax, and at 5 we will start week 10. Okay. Let me write on the screen.
Sir, is it the last session of mathematics class?
Okay, so just a quick feedback. So far, is everybody with me? Like, are you able to understand? See, because we are very much into the course. Okay, so you are not able to understand, do let me know. Okay. And, if you are really unable to understand any concept also, then you should definitely look into the hobby. It's very good time. Daily you should spend at least 4, 5, 6 hours on math course. Okay, so if you are able to follow, then you can relax and you We'll definitely do it. Okay, so let's resume. We'll start with week 10 now. So week 10 is all about complex numbers. Right? So the complex number is written as x plus iy, where x is the real part, is also denoted as re of z, and I is the square root minus 1, which is a complex number. And as I is square root minus 1, I square will be minus 1. And y is the imaginary part. And it is also denoted as Im of z. So this is a complex number. And once we know how a complex number can be written, then given any complex numbers to us, we should be able to do this addition, multiplication, conjugation, absolute value, and right. So let's say you have z1 and z2 like this. Addition will be, I'll do it quickly, okay? So the addition will be z1 plus z2. That's okay. So z1 plus z2 will be, just have to add the real parts and the complex parts. Right? So this will be the addition. What happens to multiplication? When I do the multiplication, we just have to do it like how we do it with polynomials. That's it. So this, treat this as a 2-degree polynomial. x1 plus iy1 it's multiplied with x2 plus iy2. Right, so what you have to do, you have to take this term, multiply it with this, take this, multiply it with this, take this, multiply it with this, and take this, multiply it with this. Have 4 terms. We'll have 4 terms. And two terms will get added up and they will just become a complex number. So x1, x2 and minus y1, y2. So I'm writing it directly, okay? So I hope you guys are following. This will be x1, y2 plus x2. So even the multiplication will give us another new complex number. How will the conjugation look? Conjugation is denoted like z bar. If I have to do the conjugation for z1, it will be z1 bar. Z1 bar will simply be, I just have to negate the complex part only, not the real part. Or in other words, in place of I, you just replace it with minus I. So that will just become x1 minus iy. If at all I have some complex number, 3 minus 2i. I have to write the conjugation of this, then it will just become 3 minus 2. In place of I, you just write minus. This will just become 3 plus 2i. Okay. So this is how conjugation works. And what about the absolute value? Absolute value is mod z. Right. So absolute value of z1 will be square root of the real part square plus the complex part square. Right. So mod z2 will be square root x2 square plus y2 square. Right. And finally, how division works? If I have to divide two complex numbers z1 and z2, even the result will also be a complex number, but may not look straight away. So you can think that this will be a rational complex number, but we can do some manipulations and make it a complex number. Right. So how we do it? We use the conjugation. So we'll do we will multiply and divide by the denominator's conjugation and then simplify it. Okay, so you can do this, I guess. This, what I will do is I will just multiply and divide by the denominator's conjugate term, which is x2 minus iy2 And in the denominator, I will have x2 minus y by 2. What will this give me? The denominator will now be a real number, right? Because the product of the complex number itself and its conjugate will just give us x2 square plus y2 square. Right? I hope you all know this. So the numerator is just the product of two complex numbers that you can use from this. You know how to multiply, and then you get a complex number. Okay, so it will be like a very ugly expression, but you can write it on your own. Alright, so these are some operations with complex numbers. And moving on, there are few more properties of these complex numbers. Right, so you have two complex numbers with you, z1, z2 again. You should know z1, z2's conjugate, right? The product. This product's conjugate will be product of conjugates, right? So that is one property. Similarly, it works with absolute value also. So the product of absolute value of the product will be product of absolute values. Similarly, when you divide two complex numbers and take the conjugate, it is equivalent to take the conjugate of the numerator and conjugate of the denominator. Same with absolute value also. If you are computing the absolute value z1 by z2, you can compute the absolute value of z1 divided by absolute value of z2. And one good property is the absolute value of the complex number and its conjugate is the same. Okay, so you can use this. So all these properties are, we'll use this to simplify a complex number or to compute. Okay, so for example, here I have given a very big expression, right? So 1 plus 2y by 1 plus 2y whole conjugate plus 2 plus 3y whole absolute value, right? So we'll use these properties and these things, operations, and simplify this particular expression. Okay, so take a minute or two. Try to put your pen on the paper and try to solve this. Okay. So you guys solve it. Parallelly, I will also solve. So you start with this particular expression, right? So 1 plus 2y by 1 minus 2y is whole conjugate. I just have to take the conjugate of the numerator and conjugate of the denominator. That I will get as 1 minus 2y divided by 1 plus 2y plus 2 plus 3. Right? So from here you can solve it in two ways. Either you can multiply these two, right, and take them in the numerator overall divided by 1 plus 2y, or you first do the division between these two. So we know how to divide, right? So 1 minus 2y divided by 1 plus 2y. This I have to do 1 minus 2y into 1 minus 2y divided by 1 minus 2y. Why? Because that is how I have to write, right? So if I am dividing two complex numbers, I have to get a complex number back. So for that, we need to multiply and divide by the denominator's conjugate. So if I do that, the numerator will just become 1 minus 2i whole square, whole divided by the denominator will just become 1 square plus 2 square. I can simplify this further, 1 minus 4i, so plus 2i whole square divided by 5. This will be 1 minus 4i. So 2i whole square will become 4i square. I square is minus 1, so it will become minus 4. So 1 minus 4 will give me minus 3. So this will be minus 3 minus 4i divided by 5. And so this part. So this part is minus 3. So I can write this as minus 3 by 5 minus I 4 by 5. So this part is this. If I substitute, I'll have minus 3 by 5 minus I 4 by 5 plus 2 plus 3. So now I can sum these two together because both of them are reals. I can add these two. Right, so this is how I add two complex numbers, right? So this is one complex number, this is another complex number. I know how to add these two. This will be 2 minus 3 by 5, which will give me 7 by 5. Right, so 2 minus 3 by 5 is 7 by 5. And then 3 minus 4 by 5 is 11 by 5. So if my complex number is 7 by 5 plus 11 by 5i, what is the absolute value of it? It will just be square root of 7 by 5 whole square plus 11 by 5. That's it. So you just have to simplify this. And this will give you some real number. Right, so it will be 49 plus 121 will be 1. Okay. Yeah. 170 by square root 140 by 5. So you can cross check this, I may be wrong, but you can compute. You see, this big expression is just boiled down to one small real number, right? And how did I came to this particular value? I just use all these properties. And in week 10, as I said earlier also, this arithmetic with complex numbers and properties of these complex numbers are really, really important. And in every problem, you are going to use it. If we ask you some 3, 4, 5 problems in the end term, all 5 problems will definitely use one of the properties. So you should really be practiced with these particular properties. Okay, so that is one part of week 10. The next part is you should know this Euler's form. So given a complex number, you should be able to write them in this polar form. Something like I have given you 1 plus I. Okay. And if z is 1 plus I have asked you z bar 100. So you can't sit and do 1 plus I whole bar 100. Right? So there should be a smart way, no? The smart way is like if you are unable to do it in this complex domain, like rectangular domain, coordinates domain, or to convert to polar form. Okay, so that is where this complex Euler's formula will help us. So what is Euler's formula? Again, e power it I theta is actually equals to cos theta plus I sin theta, right? And its conjugates form will be e power I theta's conjugate will be e power minus I theta. As I see, just remember this conjugacy is always like wherever you see I, replace it with minus I. So e power I theta's conjugate will be in place of I, if you write minus I, it will be e power minus I theta. And if you write it in this form, it will be cos theta minus I sin theta. Okay, just be careful about it. Okay, now just a simple example, just to get some hands-on experience on how to use this Euler's formula. Okay, so you have 1 plus e power I pi by 4 plus e power I 3 pi by 4 whole absolute value of 1 plus e power I pi by 2 plus e power I 3 pi by 2. So all you have to do is use Euler formula and some standard cosine and sine values. Right, so if I use that, I'll get 1 plus e power I pi by 4. Here theta is pi by 4. If it is pi by 4, it will just become cos pi by 4 plus I sine pi by 4 plus cos 3 pi by 4 plus I sine 3 pi by 4. Right, and the denominator will be 1 plus cos pi by 2 plus I sine pi by 2 plus cos 3 pi by 2 plus I sine 3 pi by 2. Right, so now you should know the standard values: cos pi by 4, sine pi by 4, cos 3 pi by 4, sine 3 by 4, sine 3 pi by 4. Right, so we know that this will just be 1 plus cos pi by 4 is 1 by root 2 plus I sine pi by 4 is 1 by root 2 plus cos 3 pi by 4 is 1 by root 2 or minus 1 by root 2. Minus 1 by root 2 plus sine 3 by 4 will be. So you should be knowing these things, okay? So I'm writing it now, but just see the standard sine and cos values. And cos pi by 2, you all know. Yes. I sine pi by 2, sine pi by 2 is 1. Plus cos 3 pi by 2 is plus I sine 3 pi by 2 is okay. So if you see the denominator, right, so these two will get cancelled out and the denominator will simply be 1. Even though it is given like this, I just simplify, the denominator is just becoming 1. And I have to work with only the numerator. And now the numerator is again here also 1 by root 2 and 1 by root 2 will get cancelled out. I'll have 1 plus root 2. Right? And we know how to compute the absolute value of this complex number. So this will simply be square root of 1 plus 1 square plus square root 2 square. Simply 1 plus. So what did I use? I used the Euler formula and some standard cosine and sine. Right? So with these two, let's solve this final problem. Yeah. Given this complex number to you, Z, 2 root 3 plus 2y, you have to find maybe I'll give one more. Okay, so Z bar 36, something like this. Okay, so we know first part, second part, even the third part is slightly okay, I guess. Let's see. So the first part is really easy, right? So you should be able to do it very easily. So just the conjugate. It will just be 2 root 3 minus 2y. What is the absolute value of z? It will be square root 2 root 3 whole square plus this one. Right? And if you just simplify this, you will have 4 into 3 plus 4 And we will have 12 plus 4 is 16. Square root 16 is 4. So the absolute value will be 4. Now, what is the square root of? So this is like square root of 2 plus root 3 plus 2y. Right? Now tell me, what will you guys do? Okay, so let's finish this one. This is the fourth part. We'll come to third part. So let's finish this fourth part, which is 2 root 3 plus 2y whole square into its conjugate. If I take the square, this will be 4 into root 3 whole square, which will be 4 into 3, which will be 12, plus 2ab, right? 2ab is like 8 root 3i plus b square. B square is 2i square. So 2i square will just become 4i square. I square is minus 1, so it will become minus 4. This will just be minus 1 into 2 root 3 minus 2. So this is 8 plus 8 root 3i, 2 root 3 minus 2. Right, so here you can do it in many ways. What I will do is I will pull out 8 from this first term, first factor, 2 from this second factor, and it will just become 16, and then it will just look 1 plus root 3i, root 3 minus I. Right, so from here I will just do the product straight away. I'll have root 3 minus I, when 1 gets multiplied, plus 3i minus root 3i square. So it will just be root 3 minus I plus 3i. I square is minus 1 again, so it will have plus root 3. So 2 root 3 plus 2i, 16 of 2 root 3 plus 2i. So 2 root 3 plus 2i, what is 2 root 3 plus 2i? This is z. This is 16z. Z square into z bar is simply 16z. Do I have to do all these things to reach here? That's what I will discuss in 2 to 3 minutes. But if you do just blindly follow the arithmetics properties, you can solve it. Still you can solve it. Okay.
I got same answer.
Okay. So let's also solve fifth one. Okay. So for that we need ZZ bar. So what is ZZ bar? Absolute value of Z whole square. Right? Or if you just multiply and see, you will get. So ZZ bar is 2 root 3 plus 2i into 2 root 3 minus 2i and whole square, and its absolute value. Now what will happen? Write this in different color. Okay, now this will be, if I take the product of Z and Z bar, I will get, so you'll solve and see. So it will just become 2 root 3 whole square plus 2 square and its whole square. Okay, so if I simplify this, you'll get 4 into 3, which is 12, 12 plus 4, 16. So it will just become 16 whole square, which is 56. So the absolute value for a real number will just be the positive value. That's it. So absolute will not play any role. Okay, so this will just become 256. So we have solved part 1, part 2, part 4, part 5 without any difficulties, right? So let's come to part 6. Let's see even if we can do part 6 without any difficulties. See, z power 36, which is 2 root 3 plus 2y whole power 36. And so we'll take even 1 hour 30 minutes will not be sufficient just to solve this. Right? So what is the best way to do? So even square root z, here we kind of stopped, right? So square root of 2 plus root 3 plus 2. And so what is the best way? The answer is converting this complex number into its polar form. So trying to convert. So if you are unable to do it, then that means there is some smaller or easier way, or the easier way. And the easier way is to convert the given complex number into its polar form. Okay, so how do I convert? That is the next question, right? So I have 2 root 3 plus 2y as my z. So I have z is equals to 2 root 3 plus 2y. And all I know is if I have to convert to some polar form, e power I theta, I need to have some cos theta as my real part plus sin theta as my complex part. Right? So I just have to find that theta where cos theta will give me some scalar of 2 root 3 and sin theta will give me some scalar of 2. So, okay, so that is where we are reaching. I will just pull 2 out. I will have root 3 plus I. Root 3 plus I still feels unfamiliar to us. What I will do is I will multiply and divide by 2. So 4 will be outside. This will be root 3 by 2 plus I 1 by 2. Okay, so now the real part of z is root 3 by 2, which should be my cos theta. The imaginary part of z is half, which should be the sin theta. Is there any theta? So that sin theta is half and cos theta is root 3 by 2. And the answer to it is yes. When theta is 30 degrees, we have sin 30 to be half and cos 30 to be root 3 by 2, right? And theta 30 degrees is pi by 6. Right in pi, in terms of pi. So I can replace this square root 3 by 2 plus I into half as 4 into e power I pi by 6. Right? And by writing it like this, what will we achieve? Is the question, right? So if z is 4 into e power I pi by 4, what are we achieving here? So we can solve all these things in a very faster and smarter way. Right, so how will we do that? So here is the way. So z bar will be again, it will just be, in place of I, it will just be minus I. 4 into e power minus I pi by 4. I pi by 6. Okay. So that is z bar. What is the absolute value now? So absolute value is really, really interesting. So this will be absolute value 4 into e power I pi by 6. This is like absolute value of 4 into absolute value of e power I pi by 6. Right? And if you see, observe carefully, e power I theta, absolute value of e power I theta, square root cos square theta plus sin square theta, and we all know cos square theta plus sin square theta is 1. So square root 1 will be 1. So if you write this complex number as some r into e power I theta, where r is just the radius. So in polar form we have two things, right? So the radius and the angle. So if you written your complex number as r into e power I theta, when you take the absolute value is basically the distance, right? The radius. So you can directly, this will go to 1. You can directly just write the radius itself. It will just be 4. So here, what we did, we just computed square root of 2 root 3 whole square plus 2 square, and then we got 4. Right? But here, you can get it directly. Just the radius r will be your absolute value. And what about the square root z? Square root z earlier we were not able to do. Can we do it here? So this will be square root 4 e power I pi by 6. And if I do the square root, I will have 2 into e power I pi by 12. Right, that's it. And if I know cos pi by 12 and sin pi by 12, I can easily write this. So this will simply be 2 times cos pi by 12 plus 2 times sin pi by 12 I. Yes.
Sir, how this will be 1, sir?
E power I theta.
Yes, sir.
So e power I theta, if you see, this is your complex number, right? Cos theta plus I sin theta.
Yes,
So
sir.
what is the absolute value of this cos theta plus I sin theta?
Absolute
Square
value.
root of, oh, sorry,
Yeah, go ahead.
square root of the real part square plus the complex part square, which will be
So it
cos
will
square
be
plus
1.
sin square, will be 1. No?
Okay, got it.
So that is all. And now you see this third part, earlier it was like slightly trickier. Whereas here, I can be able to do. I can be able to compute. Then cos pi by 2, even if I don't know, I can do it, right? So just fix value, right? So I can use calculator or whatever. Or I will use the properties, some known properties. I can compute at least. I have it in the complex. I have it in the complex form. So some real part plus some complex part into I. Earlier, I was not able to. What happens to the fourth one? Fourth one will also be z square. Z square will be 4 e power I pi by 6 whole square into z bar. Z bar is 4 into e power minus I pi by 6. What will we get? This is like 4 square into e power 2 I pi by 6 into 4 into e power minus I pi by 6. Now this is 4 cube, right? The constants will get multiplied together, and even the exponentials will just become e power I pi by 6. Right, so what we got, it is just 4 cube into e power I pi by 6, and you know z is 4 into e power I pi by 6. From here you will have 4 square into z, which is 16z. You see this? So we have done at least comparatively larger calculations here, right? So here the calculations are simple. Even this also, if z I know 4 into e power I pi by 6, it will just become 4 into e power I pi by 6 into 4 into e power minus I pi by 6 whole square absolute value, right? So e power I pi by 6 and into e power minus I pi by 6 will just become e power 0, which will be 1. So 4 into 4 will become 16, 16 square will become, right? So what happens to z power 36? Can I compute z power 36? So 4 into e power I pi by 6 whole power 36. Can I do this? The answer to this is yes. Right? So this will just become 4 power 36 into e power 36 I pi by 6, and it will become e power 6 I pi. And e power 6 I pi is 4 power 36. E power 6 I pi will just be cos 6 pi plus I sin 6 pi. Right? And we know sin 6 pi is 0. Right? So it is just a multiple of 2 pi. We know sin 2 pi is 0. Sin 6 pi will also be 0. What happens to cos 6 pi? This will just be 1. Right? So what you got eventually, we got z power 36 to be 4 power 36. That's it. It's not even complex number. Earlier your z is a complex number. It has some complex part in it. When you take higher powers, like z power 36, it just became 4 power 36. There is no complex part. Okay? So that way, so this conversion will help us to solve problems faster, and you won't go wrong also. So here the steps are very minimal. So the chance of going wrong from one step to next step will be very less compared to the earlier that we used. Okay. And for fourth part can be really really smart. Okay. Even not both cases, you can see that z bar is absolute value of z whole square. I am taking z square into z bar. It is nothing but z into absolute value of z whole square. If you had already computed a absolute value of z, then you don't have to do anything. It is just like 4 square, which is 16z. Okay, so these are some tricks you should definitely. It will come when you solve more and more. All right. So in week 10, as far as I want to emphasize more on the complex numbers, it's arithmetic. Like you should definitely know this addition, multiplication, combination, absolute value, and division, and these properties. And in these properties itself, I will add this mod zz bar. Sorry, zz bar is mod z whole square, which is mod z. Okay. All right. Uh, okay. So finally, let me talk about roots of unity. Our time. Okay. Before I talk about roots of unity, any doubts in this?
Yes, sir. In the fifth problem, still we have to calculate the 4 to the power 36. It is
Which
not
one? Sixth one. Okay.
Yes.
If you have to compute 4 to the power 36, we will give appropriate numbers. No, here I took z bar 36. It will be much smaller only, which can be calculated, which will be lesser than 9 digits. Okay, so you can use calculators for that. Any other doubts? Anything else? Okay. Okay, so finally we'll end our discussion by talking about roots of unity. So basically, roots of unity, these are the complex numbers which, when raised by power n gives us 1. Okay, so in other words, I have a complex number. If I raise it by power n, if it is giving me 1, then these complex numbers are called the nth root of unit. So here z is a complex number and n is a positive integer. So we are raising it by power. Powers are always integers. Note. Okay. So now, what exactly this? Among these roots of unity also, you don't go beyond cubed root of unity, okay, or fourth root of unity. So the very simple base thing that we know is the square roots of unity, right? So the roots of this x square minus 1 quadratic equation, which will be plus 1 minus 1, right? So these are the two roots of unity. So when taken square of plus 1, I'll get 1. You take the square of minus 1, you'll get 1. These are square roots of unity. Okay, so these are the roots of unity. So what are cubed roots of unity? So when I take the cube of that particular complex number, I should get 1. Okay. So we know that 1 is definitely a cubed root. And the other one, omega, no? What is omega? I just have to solve it. You can solve it also, okay? So it's just you factorize it. If you forget, you can do it like this. As of now, I forgot. I do it like this. So x is equals to 1 is this, and the other two roots comes in from here. So x, the other two roots will be minus 1 plus or minus root 1 minus 4, which is minus 3 by 2. So it will just be one root will be minus 1 plus root 3i by 2. The other one will be minus 1 minus root 3i. Okay, so these are the cubed root of unity. Okay, so like this. So the nth root of unity is just all the roots of this equation, this polynomial x power n minus 1. So you'll have n roots starting from plus 1 to nth root. So these are nth root of unity. And mainly this is better understood with this curve, this graph. So you have a unit circle in your complex plane. This is the unit circle. And if I am talking about cubed root of unities, the cubed root of unities will lie on the circle. So all the roots of unity will lie on the circle. Okay. But the difference is, if you are looking at the cubed root of unities, you will only have three values. Right? So there are only 3 complex numbers. When we do cube, it will just give me 1. If I am looking at the fourth root of unities, then the fourth root of unities will be this. Okay, so as this is a complex plane, this is the real part and this is the complex part. Okay, so that is why a cubed root of unity, it will have 1, and this point is minus 1 plus root 3i by 2. It's minus 1 minus root 3i by 2. If I want fourth roots of unities, so the fourth roots of unities are 1 I minus 1 minus I. Because when I take all these 4 complex numbers to the power 4, I'll get 1. So those are cubed roots of unities. So there is a general formula to find the nth root of unities. Okay. So it will just be, I'm writing just the formula, okay, so you can just go back and look. So let's say you have Z1, Z2. So Z0 is simply 1, okay, I'm not writing. You can write it. Z0 is the first one. But you will have other n minus 1 nth root of unities, where Zk, the kth Z, is simply e power I 2 pi k by n. So you can write this in this expression by writing 1 as e power I 2 pi. Okay. So I can write 1 as e power I 2 pi, and this will be my first root. For the second root, what I will do, I will just take the square of this. For the third root, I will just take the cube of this. For the fourth root, I will just take fourth power of this. Okay. So that will give me the nth roots of unities. Right, so that is how it is. So my z bar n is 1. I can write this as z bar n as e power I 2 pi. Right, now all my z's will be e power 2 pi by n. Right, so if I want, I just have to take powers now. So I have z as like this. So this power 0 will give me 1. This power 1 will give me e power I 2 pi by n, which will be the next second nth root of unity. And if I take power square, I'll get the third nth root of unity, and so on. So we'll have n such points, right, throughout this circle. And if you have observed, they will all be equidistant from each other. Okay, so they will all be placed. The distance between any 2 points will not be the same on the circle. So distance, I mean this. Okay, so this is basically the nth root of unity. And again, why we bother is again to solve some few problems like this. So if you take the cubed root of unity, so let's say omega is cubed root of unity. Okay. So then we will be like omega plus omega square. What is omega plus omega square? Something like this to simplify few expressions. But as I said, this roots of unity, if you don't have time, you can skip. If you have time, just look at it. Let me re-emphasize what are the most important concepts. So 1, 2, 3, 5, 6 are really, really important. If you are not good at it, then it's very hard for you to even pass. Yeah. But if you are good at 1, 2, 3, 5, 6, then look at 4 and 7 also. And if you want 100 out of 100, then along with these concepts, also look into the other concepts. So if you just follow these concepts, I can guarantee you that you can expect some 75 to 80% of week 9 and 10 related questions. Okay, I think that's all I have. And please follow through this session. If you haven't followed now, at least go back, watch it in the YouTube once and see what all we discussed. And practice more problems related around these concepts. So for better practice for it. Alright, so that's all for today. And tomorrow is the second revision session where we will revise week 11 and 12. And Friday we will do the mock session. Okay. So thanks all. And have a great day. So prepare well. All the very best for your exam.
Thanks, sir.
Yeah.
Thank you, sir.
Thank you.
Thank you, sir.